from this we know that 160 grams of the ore or iron 3 will give us 2 times 56 grams of iron. This is the same thing as 112 grams. 112 grams. So what we have in the other side is, let me have I clean that one. No. Let me just quickly get that thing back. Times 80,000 divided by, okay, from what we have in this, the mass of iron 3 ore oxide that we have there will be in every balanced chemical equation. One of the things you get there is the theoretical yield of every product we have and the ideal environment. Let me just use that word, ideal. So what you can get ideal, but in the real in the practical aspect of it, let's say in the real life um, reaction, we find out that most of those things are not likely to be like that. Sometimes due to some conditions, a lot of things tend to change. But here in this question, we're looking at how we can get this the theoretical yield of a substance of iron. The question said an iron ore is known to contain 70% of iron 3 oxide. The mass of iron metal which can theoretically obtain from 80 kg of this ore is, actually this we are going to be calculating to find out how the mass that we can get from this. So based on the mass we are giving the options. We have options there: 35, 39.3, 70, and 78.4 kg, all of them in kg. So look at the balanced chemical equation of what we have. So from this balanced chemical equation, we are going to be looking at how we can get this thing done. Now we were given 80 kg, that is the same thing as 80,000 grams, and in this 80,000 grams, 70% of it is what? Is iron. Is iron 3 oxide. So in that case, we need to find out this what we have there, the mass of the iron that we have in iron 3 oxide we have there. So what are we going to do next? That means mass of iron 3 oxide, that means it will be 70 over 100 times 80 over 1. 80,000 times 70 divided by 100. So the mass of iron we have here will be grams. We have iron 3. Iron 3 we have there is this. So from this balanced chemical equation, looking at the equation, we know that 1 mole of this iron 3 oxide will give us 2 mole of iron. So now we have the iron 3 oxide as present. So what I'm going to do next, we'll look at it very well. Now we get the mass. The molar mass of that we have iron is 50, iron is 56, and then times 2 because we have 2 here, plus 16 times 3. So times 2, we have 1 1 2 plus 16 times 3, that will give us plus 112. We have 160 grams. So for the iron, we have it to be, now let's go down. Yes, I remember. So from what we have here, let's just quickly do it fast. We'll be faster now. Let's do it very fast. From this, we know that 160 grams of the ore or iron 3 will give us 2 times 56 grams of iron. This is the same thing as 112 grams. 112 grams. So what we have in the other side is, let me have I clean that one. Let me just quickly get that thing back. Times 80,000 divided by, okay, from what we have in this, the mass of iron 3 ore oxide that we have there will be, so from here, what mass of iron metal are going to get, then that will be equal to 1 1 2 over 1 C 0 times 5 6,000 5 6,000. Then we can multiply to times 112 divided by 160. What we have here will be, we have is equal to 3 grams. So if we convert it to kilogram, because the answers we have here is in kilogram, what it will be, it will then be, don't I have there? Okay, I'm sure that thing is correct. Okay, this should be correct. I think I made a mistake there. So what we have here is the answer. The answer is this. All right. Thank you so much for being part of the class. I'm expecting to read your comments, and subscribe if you have not subscribed, share and like. Thank you so much.